Hello guys, hello friends, hello G's. It's your boy again, Falling with a Star. So guys, I want us to look at the skeletal muscle, the structure of the skeletal muscle. So when you take the whole skeletal muscle, this is the whole skeletal muscle. It is being covered by a connective tissue. To be precise, it is being covered by a dense, irregular, fibrous connective tissue called the epimysium. The epimysium. You understand? And when you take them, the whole skeletal muscle, it is being made up of bundle of what muscle fibers, So when you look at this, it consists of many muscle fibers coming together to form this bundle. And I've taken one, and this is one of the bundles. And these bundles, they are called fascicles. And these fascicles too are in turn being covered by a connective tissue, also a dense irregular fibrous connective tissue called the perimysium. You understand? And when you take these bundles, I said that what comes together to form the bundle? Muscle fibers. So these are the muscle fibers. I've taken one here. These muscle fibers can also be called the muscle cells. They are being covered by a dense irregular fibrous connective tissue called the endomysium. And these muscle fibers contains many myofibrils. So this is one of the myofibrils. And these myofibrils are made up of two proteins called the thick and thin filaments. It's made up of what? Two proteins called what? The thick and what? Thin filaments, which together we call them what? The myofilaments. So when you take the myofibril, it is being made up of two myofilaments called the thick and thin what? Filament. Let's look at the whole unit of the skeletal muscle. You see, this is the epimysium covering the whole unit of the skeletal muscle. The epimysium is further being covered by a certain connective tissue we call the fascia. Let me write it here. Fascia. Called the fascia. You understand? And this fascia is the one covering the epimysium and connecting the what? The muscle to what? The bone. It connects the muscle to what? The bone by either a tendon or what? A tendon sheath called the aponeurosis. You understand? So now I want us to look at the structure of the skeletal muscle fiber. So let's take the muscle cell, which is also called the skeletal muscle fiber. When you take the muscle cell is elongated and cylindrical in shape. It is also known to be multinucleated. You see, this one nucleus, this another nucleus, this another, so multinucleated. And you can see that these nuclei, they are being found at the peripheral part of what? The cell. You understand? They are being attached to what? The membrane of what? The muscle cell. You understand? Which is the membrane of the muscle cell is called the sarcolemma. So when you hear sarcolemma, we are talking about the plasma membrane of what? The muscle cell. And the cytoplasm of the muscle cell is called what? The cycoplasm. So this skeletal muscle is multinucleated, and this as a result of what? The fusion of what? Myoblast. You see, myoblasts, they fuse together to give us this what? Muscle cell, and each myoblast contains what? A nucleus. So when they fuse together to form this muscle cell, they in turn make this muscle cell look what? Multinucleated, having many what? Nucleus. You understand? And I said these nucleus, they are being found at the peripheral part of what? The cell, leaving the center space. So they leave the center space for the myofibrils. So you can see that the myofibrils are in the what? In the center space. You understand? So this nucleus, they have been attached to the peripheral part, leaving the center space for this what? Myofibrils. And these myofibrils are being covered by these things called the cycloplasm reticulum. So the myofibrils are covered by what? The cycloplasm what? Reticulum. So you can see that they are being covered by the cycloplasm reticulum. And what is the function of the cycloplasmic reticulum? The cycloplasmic reticulum is the storehouse of what? Calcium. The storehouse for calcium. And this calcium, later we will find out that this calcium helps in what? Muscle contraction by binding to what? Troponin C. You understand when we get there. And this cycloplasm have this receptor. Put this in your mind. It has this receptor called the rhinodine receptor. This rhinodine receptor, after receiving a stimulus, and specifically the stimulus come from another receptor that we will look at, and that receptor is being found at the T tubule. We will look at that. And when after receiving that stimulus, which is in the form of voltage, it causes what? Voltage gated calcium channels to open for calcium ions to flow out into the the cytoplasm, which is the cytoplasm of the muscle fiber. So when you look at the muscle cell, the skeletal muscle cell, you see that from the surface, which is the sarcolemma, you see that there is this invagination called the T tubule. Invagination called the T tubule, and the function of the T tubule is to conduct impulses or electrical signals traveling on the surface of the sarcolemma into the cell, and specifically to the tube-like cytoplasmic reticulum. So they conduct the impulses which were traveling on the surface of the cell down to the cell, and specifically to the tube-like cytoplasmic reticulum. So the cytoplasmic reticulum, they are tube-like, and this cytoplasmic reticulum, at their ends, they are very large at their ends. Their ends are very large, so you can see that their ends are very large, and these ends make contact with the T tubule. So when you take every one T tubule, you can find these two large ends of the cytoplasmic reticulum making contact with it, and together they form a triad. So this one end, and the large end of the cytoplasmic reticulum is called the cistern. So we call it the cistern of the cytoplasmic reticulum. The part that are deepening, those are the parts called the cistern of the cytoplasmic reticulum, and it makes contact with the T tubule. So two of them making contact with the T tubule, and together they form the triad. The triad, you understand? The triad. And this T tubule, let's look at something here. This T tubule also contain a receptor called the dihydropyridine receptor. The dihydropyridine receptor. And this dihydropyridine receptor, after receiving stimulus, causes voltage gated calcium channels to open, specifically L-type voltage gated calcium channels. L-type voltage gated calcium channels to open for calcium channels to enter into the cytoplasm. And this calcium and this dihydropyridine receptors, they are mechanically linked to the rhinodine receptors of the cytoplasmic reticulum. So you can see that this is the dihydropyridine receptors mechanically linked to the rhinodine receptors of the endoplasmic reticulum, and through that they causes the rhinodine receptors to also receive the stimulus. And I said that when the rhinodine receptors receive the stimulus, they also causes voltage gated calcium channels to open for calcium to come into the cytoplasmic reticulum, and calcium will be used in muscle contraction by binding to troponin C. We will look at that. You understand? Hello guys, hello friends, hello G's. It's your boy again, Falling with the Stars. So guys, let's continue with what we're doing. So I said that when you take the muscle cell, it is being made up of many myofibrils, and these myofibers are further being made up of something we call myofilaments. And these myofilaments, we have two types. We have the thin myofilaments and we have the thick myofilaments. The thick myofilament is also called myosin, and the thin myofilament is being made up of three components, which is actin, the troponin, and tropomyosin. So the actin, troponin, and tropomyosin, they come together to form the thin filament. So this is the thin filament, and this is the thick filament. You understand? The thin filament and the thick filament. And how they are being arranged gives the the characteristic striation of the skeletal muscle. I said that the skeletal muscle structurally they are being striated. You understand? Structurally they are striated. You understand? So this is because of the arrangement of the thick and thin filament. So let's look at this arrangement. You see, this is a Z-disc, this is another Z-disc. From one Z-disc to another Z-disc, we call it a sarcomere. From one Z-disc to another Z-disc, we call it a sarcomere. A sarcomere. And this sarcomere is known as the structural and functional unit of the muscle cell. The structural and functional unit of the muscle cell is called the sarcomere. And you see this thick filament from this end to this end. From the end of this thick filament to this end is what we call the A zone. is what we call the A zone. A zone. A zone. You understand? So A zone is the and from one end of the thick filaments to another end of the thick filament constitute what? The A zone. And you see that from that pattern, there are overlaps. You can see some of the thin filaments here. You understand? There are overlap. Where there is no overlap between the thick and the thin filaments, you see from this end, the end of this thin filament to the end of this thin filament, you see that for that pattern we have only what? Thick filaments. And that part is what we call the H zone. The H zone. The H zone. So the H zone is from the end of one thin filament to the other end of one thin filament, where there is no overlap between what? The thin and the thick filament. This part is called the H zone. Understand? And what is running here is called the M line. The M line. The M line is being made up of a protein called myomesin or C proteins. So the M line is being made up of these proteins, myomesin and what? C protein. The Z disc, you can see that this thin filament is being what? Connected to this Z disc. And this thin filament, they are being connected to the Z disc by a protein we call nebulin. A protein we call nebulin. A protein we call nebulin. And you see these thick filaments too, they are being connected to these Z discs. And they are being connected to these Z discs by a protein we call titin. A protein we call titin. A protein we call titin. So titin connects the thick filaments to what? The Z discs. And nebulin connects the what? The thin filaments to what? The Z discs. You understand? And we have something we called I've talked about the sarcomere, I've talked about the A zone, the Z disc. So let's look at the Z disc. The Z disc, is being made up of a protein we called alpha actinin. The Z disc is being made up of protein we call alpha actinin. A protein we call the alpha what? Actinin. The alpha actinin. So A zone is known as anisotropic zone, and where we have only the thin filaments, you see the thin filaments from this end to this end constitute the I band. From this end of the thin filaments to this end of the thin filaments, we call the I band called the isotropic band. You understand? And here to here is the what? The A band and isotropic band. And where there is no overlap between the thick and the thin, only here from one end of this thin filament to this thin filament, that space here is the H zone. The A zone. And the M line is being made up of the protein we call myomesin and what? C proteins. The Z disc is also made up of protein we call alpha actinin. The thin filament is being connected to the Z disc by a protein we call nebulin. The thick filament is being connected to the what? The Z disc, and also the M line by a protein we call the titin, which is an elastic what? Protein or elastic element. The nebulin too is elastic element. You understand? So that's it.